Hey Eureka, it's Melissa, and today we're going to be talking about non-Newtonian fluids. And for today's activity, we're going to be making our own non-Newtonian fluids. But before we get started, let's talk about viscosity. Viscosity is a characteristic of a fluid, which describes how quickly or how slowly it flows. Another way you can think about it is how thick or how thin the fluid is. The speed of fluid flow, or the thickness and thinness of a fluid, depends on how much friction is happening on a molecular level between the surface and the liquid itself. A highly viscous fluid describes a fluid that is thick and that flows at a very slow rate. In this case, there's a lot of friction happening between the surface and the molecules of the liquid. An example of a highly viscous fluid is hoisin sauce. As you can see, the hoisin sauce makes its way down the cutting board very slowly. One could describe hoisin sauce as a thick liquid. On the other hand, we also have low viscous fluid, which describes a fluid that is thin and that flows very quickly. In this case, there's not a lot of friction happening on a molecular level, which allows for the fluid to flow faster. An example of a low viscous fluid is cranberry juice. As you can see, the cranberry juice quickly makes its way down the cutting board. One could also describe cranberry juice as thin. Now let's take this concept one step further. Newtonian fluids are fluids that flow at a consistent rate. This means no matter how much force is being acted upon the fluid, its viscosity remains the same. Newtonian fluids are what we know as normal fluids. This includes water, juice, or milk. We also have non-Newtonian fluids. A non-Newtonian fluid is a fluid whose viscosity changes depending on how much force is being acted upon it. In other words, the speed of fluid flow, or the thickness and thinness of a fluid, depends on the amount of pressure being applied, which can make the fluid act more like a liquid or a solid. Did you know that ketchup is a non-Newtonian fluid? When you take the ketchup bottle and flip it upside down, you can see that nothing's coming out and it's moving very slowly. However, when you shake it, its contents come out significantly faster. This is because the pressure that you're applying by shaking it is making the ketchup in the bottle act more like a liquid. See? Non-Newtonian fluid. For this activity, we're going to need water, cornstarch, and a bowl for mixing. You can lay down some newspapers or a garbage bag for less cleaning. So first, we're going to add our cornstarch into the mixing bowl. And now we're going to add a little bit of water to the cornstarch mix. And then we're going to mix. And you're going to keep adding a little bit of water every time while mixing. It'll be ready when you tap it and it doesn't splash. Until you get that, you have to keep mixing. If you feel like you need more water or more cornstarch, go ahead and add some. Okay, now it's time to get messy. Take some of the scoop into your hands. When you take it into your hands, you can see that it's runny and it's acting like a liquid. Now scoop some more and play around with it and squeeze it into a ball. Roll it as if you were playing with Play-Doh. The pressure you're applying by squeezing it is allowing the substance to behave like a solid. Now what happens when you stop squeezing and just hold it in your hand? The substance becomes a liquid again, and it looks like it's melting in your hands. It's cool, right? If you want to keep your non-Newtonian substance, you can, but if you want to dispose of it, please add more water to the mixture before pouring it down the drain. If you don't add enough water, the pressure from the water that comes from the sink will act on your non-Newtonian fluid, which can result in a clogged drain. I hope you found today's experiment interesting and that you learned a thing or two about non-Newtonian fluids. If you have any questions, ask them during our live session later on today. Stay curious, be happy, and I'll see you soon. Bye, Eureka!